He convinced Voyager to turn its camera back towards Earth, and it's what basically amounts to Earth's first ever selfie. And that picture was taken, and there was this pale blue dot 14 billion years ago, and we have no idea what happened before. Over the last 50 years, Voyager 1 has been on an incredible journey through space. It's given us remarkable insights and discoveries. Recently, Voyager 1 turned its camera back toward Earth, taking what can be called Earth's very first selfie. In that picture, our planet appeared as a small pale blue dot. This discovery seemed unbelievable until scientists carefully analyzed the data and confirmed its authenticity. Now, Voyager 1 has sent more puzzling information, even validated by the famous scientist Neil deGrasse Tyson. The spacecraft detected 500 celestial objects moving through space. This discovery could change our understanding of space exploration. Let's explore the profound implications of Voyager's latest message and how it might reshape our view of the cosmos. We are a speck in the middle of a cosmic void, occupying what we call Earth. A few decades ago, a remarkable moment in history occurred when two amazing spacecraft set out on a journey into space, marking the beginning of the space exploration era. This happened in 1965 when Gary Flandreau, a bright mind at NASA's Jet Propulsion Laboratory, faced a big challenge. He needed to figure out the best way for a space probe to reach the distant gas giants in our solar system: Jupiter, Saturn, Uranus, and Neptune. With just a simple pencil, he made a significant discovery. He realized that in the late 1970s and early 1980s, these four massive planets would align in a rare celestial dance, creating a unique cosmic opportunity. This alignment meant that a spacecraft passing by each of these planets could use their gravitational pull to gain speed, like being pushed by an invisible force. Flandreau's calculations revealed an amazing possibility. What would have been a 30-year journey from Earth to Neptune could now be completed in just 12 years, thanks to these gravity assists. However, there was a catch. This alignment of planets happened only once every 176 years. NASA didn't want to miss this extraordinary chance, so they quickly launched two identical spacecraft, Voyager 1 and Voyager 2, in the summer of 1977. Their mission was to take full advantage of this rare cosmic alignment. Little did they know that these sibling explorers would set records and change the landscape of space missions. Now, more than 45 years since their launch, Voyager 1 and Voyager 2 were still going strong. They continue to send us groundbreaking data from the far reaches of our solar system every day. Despite the age, these spacecraft are performing exceptionally well. Yet there's been a recent surprising development. Voyager 1, which is now over 14.5 billion miles away from Earth, has detected 500 unidentified objects as it travels through space. These objects are entirely new and unfamiliar to us, defying our previous expectations. One possible explanation for this unexpected discovery could be the aging components of the spacecraft. Voyager 1 started its journey in 1977, which means its electronic systems are over 45 years old. In normal situations, you might expect such old hardware to show signs of wear and tear or even fail. However, Voyager 1 has been remarkably resilient. This is thanks in part to its dual redundant computer systems, meaning it has two sets of computer components. This redundancy ensures that the spacecraft can switch between systems when needed, extending their lifespan. To keep Voyager 1's computer systems running efficiently, engineers have come up with various strategies to conserve and optimize power. The spacecraft is powered by radioisotope thermoelectric generators, RTGs. Maintaining power resources is crucial for the continued success of its mission. Voyager 1 and Voyager 2 both use simplified systems with hardwired logic for their instruments. They also feature 6 onboard computers that work together in a distributed system, providing redundancy and allowing them to withstand the test of time. Nuclear power sources on these spacecraft gradually lose about 4 watts of energy each year because of the slow decay of the plutonium they use. This natural decay process produces heat, which is then efficiently turned into electricity to keep the spacecraft working. One interesting aspect of managing this power involves turning off systems that aren't essential. Engineers carefully identify and power down components or subsystems that aren't crucial for the main mission objectives. For instance, they intentionally turn off heaters connected to certain scientific instruments. These heaters were originally meant to maintain instruments at specific temperatures for the best performance, but deactivating them significantly reduces power use, extending the spacecraft's lifespan. However, there's a challenge with extremely cold temperatures in space. Scientists need to make sure that certain lines stay warm, normally around 2 degrees Celsius. Keeping these lines from freezing is essential, because if they do, the spacecraft may lose its ability to point accurately toward Earth. So managing the spacecraft is a delicate balance between power generation, controlling temperature, and operational needs. Voyager 2 has a backup power source designed as a safety measure, which will allow it to operate one more scientific instrument until 2026. But as the power on the Voyager probes gradually decreases, saving energy becomes crucial, affecting various systems, not just the scientific instruments. One critical system impacted by the dwindling power is the spacecraft's heating mechanism. Now, the primary thrusters on Voyager 2 are showing signs of wear. So engineers plan to use the backup thrusters on Voyager 2 to ensure continued control. While these backup thrusters haven't been in use as long as Voyager ones, they've still been idle since Voyager 1's encounter with Neptune in 1989, which is about 30 years of inactivity. NASA believes there are still several more years of operational capability left in these remarkable spacecraft. This extended operational life is crucial because the Voyager probes offer unique insights into the region of space they're currently exploring. Hopefully, the day when the Voyagers are powered down is still a long way off. But when the decision to power down non-essential systems is made, it's not done hastily. It involves a careful assessment of the trade-offs between saving power and achieving the mission's scientific goals. Engineers work closely with scientists to evaluate the impact of turning off specific systems on the quality and availability of scientific data. The goal is to find a balance that saves as much power as possible while keeping the essential functions running to collect valuable cosmic information. Engineers also use adaptive power management strategies to respond to changing environmental conditions. As Voyager 1 moves farther from the Sun, it gets less solar energy. So the spacecraft adjusts how it uses power to make the most of its resources. Years of technical improvements in power management have enhanced the Voyager probe's power systems. These enhancements include better power distribution, improved battery charging methods, and advances in power regulation and control. These careful power management strategies have extended Voyager 1's operational life, allowing it to keep exploring space and sending back important data. Even though the mission was originally planned for just 5 years, the dedicated work of scientists and engineers has kept the Voyager mission going in deep space. However, it's essential to recognize that unexpected events can still happen in the vastness of outer space. Deep space is known for its unpredictability, but we have some understanding of the potential challenges we might face. One unexpected event involved Voyager 1 detecting 500 objects, which was highly unusual. This was called an anomaly because the signal arrived suddenly and unexpectedly, presenting a puzzling challenge for the research team. Despite the anomaly causing a slight communication delay, Voyager 1 continued to respond to commands from mission control. The spacecraft's antenna stayed directed toward Earth, ensuring it could receive and execute instructions. Strangely, the anomaly didn't activate the onboard fault protection systems designed to put the spacecraft in a safe mode, which typically happens when irregularities are detected. Voyager 1 continued its mission activities without triggering a protective shutdown, adding complexity to the mystery. After a thorough investigation, the anomaly was traced back to an outdated control subsystem responsible for orienting the spacecraft. The subsystem had been unintentionally transmitting data through a non-functional onboard computer, causing data corruption. The question remained, were there really 500 objects out there? Confirmation of this discovery took time due to the vast distance between Voyager 1 and Earth, causing significant communication delays. Eventually, the solution to this mystery involved redirecting telemetry data to the fully functional computer system, which was executed successfully with minimal risk. Investigating this anomaly was challenging due to the long communication delays caused by Voyager 1's immense distance from Earth. After its remarkable interstellar journey, the The spacecraft now resides about 14.6 billion miles from our planet, and radio signals take a long time to travel to and from it. The significant delay in communication presented a big challenge for the mission team. Their tasks required careful planning, executing commands with caution, and the patience to wait for a long time before getting any feedback or confirmation from Voyager 1. This unique communication process substantially extended the timeline for diagnosing and troubleshooting issues. Each message sent to the spacecraft, though subject to the constraints of time, had the potential to unravel space's mysteries and deepen our cosmic understanding. When communicating with Voyager 1, NASA's Deep Space Network, DSN, team sends commands at the incredible speed of light. The DSN is a vast network of massive radio antennas strategically positioned worldwide, which establish crucial communication links with spacecraft exploring our solar system and beyond. It plays a pivotal role in enabling two-way communication between Earth and deep space missions and conducts radar and radio astronomy observations to enhance our knowledge of the universe. This international network collaborates with various space agencies, including the Soviet, Chinese, Indian, and Japanese deep space networks, as well as the European Space Agency's tracking system. By working together, these agencies create a unified and cooperative effort to explore and investigate the mysteries of space. The DSN consists of 3 deep space communication facilities located approximately 120 degrees apart. These facilities are in Goldstone, California's Mojave Desert, Madrid in Spain, and Canberra, Australia. This strategic positioning ensures continuous coverage and observation of spacecraft as the Earth rotates, making the DSN the world's largest and most advanced scientific telecommunications system. Operating on the principles of radio wave transmission, the DSN communicates with spacecraft using its enormous antennas. Embark on a cosmic journey with Voyager 1, a spacecraft that has defied the odds and ventured into the vastness of space for over 45 years. Recently, this intrepid explorer made a groundbreaking discovery: 500 unidentified objects in its path, challenging our understanding of space exploration. As we delve into Voyager's extraordinary expedition, let's rewind to the inception of space exploration in the 1960s. Picture Gary Flandreau, a visionary mind at NASA's Jet Propulsion Laboratory, facing the challenge of reaching distant gas giants with a simple pencil. He unlocked a cosmic dance, revealing an alignment of planets that occurs once every 176 years. This celestial ballet became the catalyst for launching twin spacecraft, Voyager 1 and Voyager 2, in 1977. Fast forward to the present, and these pioneers are still sending us invaluable data from the far reaches of our solar system. Despite being over 14.5 billion miles away, Voyager 1 detected the mysterious 500 objects, prompting scientists to unravel the secrets of deep space. The longevity of Voyager's mission is a testament to the resilience of its technology. Operating with electronic systems over 45 years old, Voyager 1 has defied wear and tear thanks to dual redundant computer systems and innovative power management strategies. Engineers have mastered the delicate balance of conserving power while keeping essential functions running, ensuring these spacecraft continue their mission. However, the cosmic journey is not without challenges. The spacecraft face extreme temperatures, micrometeoroids, and cosmic radiation, all potential culprits for anomalies. The recent anomaly encountered by Voyager 1, where telemetry data was routed incorrectly, posed a unique puzzle for scientists. The 22-hour communication delay added complexity to diagnostics, requiring meticulous planning and execution of commands. Despite these challenges, Voyager 1 remains a beacon of exploration, sending messages across the vastness of space at the speed of light. The Deep Space Network, DSN, facilitates this communication, acting as the vital link between Earth and the distant probes. Imagine the anticipation of the mission team, sending commands that take 22 hours to reach Voyager 1. The time delay becomes a unique challenge, demanding precise planning and patience. Every received message adds valuable information, turning the waiting game into a strategic endeavor. Voyager 1's instruments, including the cosmic ray subsystem and magnetometer, provide crucial data about the cosmic environment. These tools help us understand the impact of cosmic radiation, extreme temperatures, and micrometeoroids on the spacecraft. As scientists grapple with the recent anomaly, intriguing hypotheses emerge. While technical glitches and environmental factors offer plausible explanations, the idea of extraterrestrial involvement adds a layer of mystery. Could an advanced civilization be influencing Voyager 1's behavior? The quest for answers continues, pushing the boundaries of our understanding of space. The data sent by Voyager 1 is not just a stream of information, it's a gateway to unraveling space's mysteries. As we wait for findings from the anomaly investigation, the possibilities range from technical malfunctions to encounters with the unknown.